Okay, I hope some of you are still with me. Putting these questions individually, so you don't have to watch the whole thing. You can just go to any questions that you're particularly struggling with or wanted to check on. So we have something on turning forces here. First off, we're just kind of got a basic picture of a metal rod or some sort of rod with an axle, and we have to say what force will make the axle move. So we've just got to have a think. Make the rod rotate about the axle. So any force that's going to interact directly with the axle in line with that is not going to do anything to turn it. Okay, none of those things are going to turn it. What we do is have to apply a force that's pardon me, going to be acting at a right angle to a line from the axle. So that would give us a turning force. That's not an option in this one. The one that's going to be an option is going to be Q here, and that's going to apply a turning force. And this is going to be useful for the next question. If you remember how you would calculate the size of that turning force or that moment would be this distance here multiplied by the force at Q. So Q is what we're looking for here. That is the force that's going to turn the rod about the axle. Now, next question. I think we must be on another planet because Pedro weighs a lot more than he did on question 2. He weighs 1,800 newtons, 1,800 newtons. And we've got some weird demon trying to lift Pedro, our rock, using this rod and a pivot. So the demon is producing a downward force of 600 newtons. Pedro weighs 1,800 newtons on this alien planet, wherever we are. It tells us that the demon cannot lift, so he may be looking smug with himself. Pedro may be looking a bit concerned, but he cannot lift Pedro. So, why can this demon not lift Pedro? What we need to do is some calculations around moments. So what we need to do is work out the clockwise and the anti-clockwise moments here. So the turning force from Pedro is going to be 1,800 multiplied by this distance here, 0.2. We need to use that. No, let's just do that in our heads. 360, and the unit is Newton meters because this is newtons, right, and this is meters, so the unit for turning force or moment is Newton meters. So in this direction there is a turning force of 360 Newton meters. Okay, so what about in the other direction? Well, we've got obviously a much smaller force from the demon, however we've got a bigger distance, so put the units, I should have left that out. Right, and that is going to give us a 300 Newton meter turning force, so the anti-clockwise moments are going to be 300 Newton meters. Now clearly 360 is bigger than 300, hence why this demon is not going to be able to shift our rock Pedro. This is a 3-mark question. It says explain using calculation. Okay, so we've done a calculation, and now we just need to give some explanation of what's going on there. We've done our moment, or done this the wrong way around, but our moment was equal to our force times distance. And then we did that calculation, and so the moment anti-clockwise is less than the moment clockwise from the rock Pedro. Okay. We've now got a 2-mark question. Let's see if I can fit this in. A 2-mark question on explain one change to the arrangement that will make it possible for this person to lift the rock. So what would we have to do? Or this demon to lift the rock. If we move the demon further this way, okay, that's going to increase this distance, and we're going to be able to lift Pedro up. So let's say move demon further away from pivot, this will increase the turning force or the moment. We could give an example, let's say e.g. 600 times 1 meter equals 600 Newton meters, and then it would turn. Alright, now embarrassingly, there is now a bike here which is going to put to shame my bike from question 1, so perhaps I should have looked ahead, but anyway, here we are. So we now have a bicycle there we go. So we have our bike. It's got even worse somehow. Never mind. There is our bike. And this is a question about gears. So we have a larger gear and a smaller gear. So let's sort of zoom in on that. And this has 48 teeth on it and this has 12 teeth on it. And we are asked to calculate the number of times the small gear will turn each second, given that the big gear turns 2 times in a second, 2 times per second. So there are a couple of ways we could kind of work this out. We could look at the ratio between the two. I suppose we could calculate the number of teeth that are going to move through a point in the second if it spins round 2 times. I think what we'll do is we'll do a ratio here. So 48 divided by 12 is going to give us 4. So for every time the big gear spins, the small gear is going to spin 4 times. So how many times does this spin per second? Well, if this big gear spins 2 times per second and the small gear spins 4 times more, then it's going to spin 8 times per second. Just to show you another way, if we did the 48 times 2, because it's going around twice per second, that would give us 96, and therefore we'd have to have this spin round 96, or 96 teeth would have to pass through each second. So let's do 96 divided by 12, and that will also give us 8. So you can, different ways that you can puzzle that one out. Generally, students do well on kind of doing that, so long as they've had a bit of practice. Oil is applied to a wheel. So if we zoom down in and we look at, I'm sure you all know with your bikes, the chain can get very oily, or is very oily. That's obviously for a good reason. Why does oil improve the efficiency of the bike? So why is efficiency improved? What I want to see in your answer is the word friction. Okay, so we're going to have friction as the chain moves through the gears. And what the oil will do is reduce friction. So the oil will reduces friction, and so reduces energy lost as heat or thermal. So that's going to improve our efficiency. Okay, so we have more. What we need to think about here is we're asked to demonstrate why efficiency is increased. So often when that happens, if we've got something like efficiency, what we want to do is we can write out the equation, if I can actually spell, and what am I doing? So if we write the equation, efficiency equals useful energy over total energy. So what we're saying is, because we've oiled the gear, there's less friction, so we've got more useful energy. More useful energy, therefore greater efficiency. So some comment about the oil reducing the friction and so reducing energy loss. Some clear, you could explain what efficiency is, or you could put the equation, and therefore say that there's more useful energy and therefore the efficiency goes up. And that will do you with trying to keep under a minute per mark. That's 11 marks total. Sorry, that question was for 3 marks. All right, I think that'll do for today. If you keep finding this useful, let me know, and I will keep going. See ya.